My chain's broken.
If you.
Not now, but it will be.
My tires have played after.
I think there's a hole in my tube.
So, today we learn the two parts of the fundamental theorem of calculus. Sound important? It is.
No.
Partly because it relates derivatives and definite integrals.
Ooh. Interesting.
Delightful.
Well, part of what was interesting is that a lot of historically the development was done by different people at different times. Like independently, people were working on derivatives, some other people were working on definite integrals, and no one really knew that they were related to one another at first. And then someone went, hey, look what we have here. So some books call it the first fundamental theorem of calculus and the second fundamental theorem of calculus. Your book calls it the fundamental theorem of calculus part 1 and part 2. It doesn't really matter. It's all part of the fundamental theorem. But there are two parts to it. This part says that if f is continuous on the closed interval from a to b, then the function capital F of x, which is equal to the integral from a, which is a constant, to x, which is a variable, of f of t dt, is differentiable on the closed interval from a to b, and secondly, that the derivative of capital F with respect to x, which is to say the derivative with respect to x of this integral, is equal to f at x. It's an awful long way, but this is what is called, and we'll spend some more time dealing with this next week, an integral defined function. This function is defined in terms of an integral. And if we want to take the derivative of that integral, if this is a variable x, then the derivative with respect to x is just this integrand at x. Okay? And we can do some problems with this. The interesting thing is, notice it just says a. It doesn't really matter what a is. A can be any constant. We're not really picky. So, for example, for this one, the derivative with respect to x of the integral from negative pi to x of cosine of t dt is cosine of x. Done.
Wow.
So for this one, notice that the lower limit is 0, which is a constant. It doesn't matter what constant it is. The derivative with respect to x of the integral from 0 to x of 1 over 1 plus t squared is 1 over 1 plus x squared. And then they get more interesting. You knew it was coming, right?
Yeah.
Well, on this one, back up for just a second. If we were taking the derivative with respect to x of f of x squared, you don't have to write this down, but what would we be doing? We would have f prime of x squared times 2x. Or we're going to do the same thing here. We're going to do the derivative just like we normally would, so it would be sine of x squared times the derivative of x squared, which is 2x. Yeah, not so bad, huh?
Oh, but it gets worse, I bet.
Maybe marginally. Slightly?
Was that sarcasm?
Pardon?
Was that sarcasm?
No.
Oh, okay.
No.
Cool. It's
No.
I know
No.
what marginally means, so I was looking at you because I couldn't tell if you're messing or not.
Have you ever seen there's a college humor thing where they talk about punctuation marks that we need today?
Maybe. Or maybe you've mentioned it before.
There's one that's called a sinceroid, where you put it instead of something else so that people know that you're not being sarcastic or cynical, that you're really being sincere.
Yeah.
And there's also sarcastices, so everyone knows that you're being sarcastic.
That ruins the point of sarcasm.
Yeah, but in written communication, it doesn't always come across. Yeah.
Yeah,
All right.
that's their fault.
How is this one different than the first two that we did?
Flip.
Yes. So if we change the limits of integration,
Negative.
right,
-4.
so it'd be negative 4x.
Oh, really
Oh,
difficult.
we combination.
What?
What was that?
It started out as combine, and then it was like, that's not the right tense. So.
Okay. I thought it was one of those I am futon. So how is this one different?
A is
I
not
wonder.
a constant.
Yeah, there's no constant in either limit of integration.
Uh-oh.
Uh-oh.
So we can't use this rule
It's not constant.
until we change it,
Uh-oh.
Why would we do that?
because we can.
So we can use the rule?
Yep. So we're going to rewrite this as the derivative with respect to x of the integral from 3x to, pick a constant. Doesn't really matter. I'm going to,
27. Oh.
okay. I did say pick a constant, so
Okay.
27 it is.
Is that going to get messy?
Nope.
27.
1 over 2 plus e to the t dt plus the integral from 27 to x to the fourth
I see.
of 1 over 2 plus e to the t dt. I see, said the blind man to his deaf wife as he picked up his hammer and saw. So for this first one, it's just flipped, so we're going to have negative 1 over 2 e to the 3x times the derivative of 3x because of the chain rule, which is 3, plus 1 over 2 e to the x to the fourth times the derivative of x to the fourth, which is 4x cubed. So not so bad. And then typically someone will take the time to rewrite that so it's a little nicer, and they'll write the 4x cubed
It looks beautiful like that.
over 2ex to the fourth minus 3 over 2e to the 3x.
Do we have to rewrite it?
It's probably going to be rewritten like that if it's a multiple choice question on the AP exam.
Ew.
It's not a huge deal. If you didn't on one of my tests, I'd be okay with that.
On a tart.
Ah.
The little friend.
Any questions about that?
No.
So that's one part of the fundamental theorem.
What is the other part?
Well, that would be this part.
Uh,
Part 2 says that if f is continuous on the closed interval from a to b, and capital F is any antiderivative of f on the same interval, then the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. We talked about this in basic terms the other day, in that if this is the derivative of this function, so if this is a rate of change, like velocity, for example, then this would be the displacement, the change in position. So you're just taking the antiderivative.
Based on our homework. Last night.
Pardon?
There were a lot of these on the homework.
Yeah. So, knowing that, we can now, sometimes this is called the evaluation part of the fundamental theorem, because it allows you to evaluate definite integrals. So, in order to do that, for this, we need to think of, well, what can I take the derivative of and end with x cubed plus 1?
1/3. Wait. No. 1/4 x. There we go.
Fourth.
There's the 4th.
Plus X.
Plus x.
And it could be plus any constant, but there's no reason to put it in there.
24.
But there's no reason to put it in there.
764x.
And what we're going to do is we're going to evaluate this from -1 to 3. This is typically the way that it's written. So evaluating that at 3, that's 81/4 plus 3 minus 1/4 minus 1.
Does it work out nicely?
Well, of course it does.
Yeah.
Yeah, 81/4 minus 1/4 is 80/4, which is 20, plus 3 is 23, plus 1 is 24. One of the nice things about these problems is you can check your answer with a calculator because you can do the definite integral on the calculator. Another kind of problem you can do is our area problems. So far, we've been restricted to area problems where the top of the function was some sort of linear. Either it made a trapezoid, or it made a rectangle, or it made some sort of triangle. But now we can do it without. So if I've got the area of the region between the curve, 4 minus x squared, between -1 and 3, and the x-axis. All right. The mistake that people make is they don't check to see where this function is above the x-axis and where it's below the x-axis. Because it doesn't ask for the integral, it asks for the area. And the area, all area gets counted as positive, whether it's above the axis or below the axis. With the integral, parts below the axis get counted as negative. Okay? So you don't have to draw anything that's great, but you got to draw something. From -1 to 3, I'm pretty sure that's going to change signs. So let's see. 4 minus x squared is a what?
Parabola.
Indeed it is.
And upside down.
And why do people call it upside down?
Because it's not right side up.
It's concave down.
Well, that is true. It is concave down.
It's not normal. So,
That's not normal?
well, it's not right side
It's
up.
a freak of
That
nature.
sounded good.
So it must be upside down.
Again, the why is that?
That's infinitely regardless.
You can. Wow.
It's terrifying. Why is it so long?
Because it just
Why did you make it so long?
No comment. So, if this is -1,
That's illegal.
what's illegal?
That was a bad joke. You can't do that. You're
And
fired.
yet here we are.
Okay.
And by the time we get over here to 3,
it's they got to.
this is way below the axis.
That's no fun.
So if we want to find the area, if we did the integral from 1 to 3, we would not get the correct answer because it would count all of this area as negative and this area as positive.
Uh-huh.
So what we'll have to do is go from -1 to 2 of 4 minus x squared dx, and then take the opposite of the integral from 2 to 3 of 4 minus x squared dx. So now we have to think of, well, what would be an antiderivative of 4 minus x squared?
4x minus 1/3 x cubed.
Indeed. So we want to evaluate that from -1 to 2. minus the same expression, 4x minus 1/3 x cubed, from 2 to 3. So let's see, this is going to be 8 minus 8/3 minus negative 4 plus 1/3 minus, and this is where sometimes people get into a problem because it's minus everything that comes afterwards. So this is going to be 12 minus 9 minus 8 minus 8/3. There's a lot of stuff going on there. By the way, if this was a free response question on the AP exam, which it won't be,
Leave it.
leave it,
Okay.
right?
Let's do it now.
Pardon?
Let's do it now. Good practice.
Let's practice leaving it alone?
Yeah.
Okay. I'll just say that if you're going to evaluate it so that you can check your answer in the book or something, let me suggest that you distribute and put all the whole numbers together and all the fractions together. It makes it a lot easier.
Okay.
If you want to check this on the calculator and you don't want to type in two different integrals, you can do it all at once, because this is also equal to the integral from negative 1 to 3 of the absolute value of 4 minus x squared dx. Because that would flip this part over here, up.
Wow.
Okay? So if it's a calculator active problem, you can just use the absolute value to find that area.
Okay.
Yes.
Also times the absolute value.
How do you what?
Also times the
Oh.
absolute value.
I'll show you.
Math.
Looks like a pterodactyl.
Because it is. Gonna fly away.
Hang on just a second.
What's the song?
Someday I'll fly away. Nope.
Nope.
Nope. Nope, 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 nope.
I'll fly away.
All right. So the integral is what? Math
9.
9. So the integral from negative 1 to 3. And then there are several places the absolute value exists on the calculator,
Math.
but I don't ever remember them. I just go second catalog. It's right there. It's the very first one.
It's also like the first one with math, I'm pretty sure.
It is math.
On the math menu,
It's one of the first ones on math.
It is the first one.
Alpha F2.
Oh, it says.
so if you go math,
Oh, wait.
then what?
Math num.
Math num?
And it's the first one.
So either way,
I see it.
so 4 minus x squared, and we've come this far, we might as well figure out what the heck this thing is.
Yeah.
2.
17.
11 and a third.
Closer.
No.
Yeah.
Yeah. 17 is closer than 2.
Now, if you had left off the absolute value,
It would not be 11 and 1/3.
no, it
would
would
be
not.
2.
Well, let's find out.
Maybe.
So from negative 1 to 3,
Just copy from above.
but you got to get rid of the absolute value.
Delete the absolute value.
Devil.
Two.
I'm saying 3.
I'm saying 2. 2. Give me a 2.
Anybody else want to bet? I have a bet for 2 and
Negative 1.
Give me a 2.
negative 1,
Yes.
Oh.
That was close.
6 and 2/3.
Mingwei said 5.
He did.
Mingwei's a liar.
All right. Last problem.
Oh.
Find the area between the curve y equals x cosine of 2x and the x-axis over the interval from negative 2 to 4. This is a calculator question.
That's easy. Just shove it in your calculator. It is.
Shove it in his words.
Here we go. That's the answer. works.
12.3.
Oh, did you guess? Were you guessing? Okay.
That was a joke, actually.
I'm getting.
The domain gives me 12.3.
I'm getting. Boop, up 20-ish energy.
20-ish energy?
The max X values.
Cosine.
20-ish.
So, since part of this is probably going to be under the axis, and part of it will probably be over the axis,
Absolute value.
we'll do the absolute value.
Yay.
I'm gonna guess in the 30s.
It is.
Oh, 40s. 40s for me.
I'm
Oh,
going
we're
20.
going up and up.
20, 20,
6.3.
20, I was closer.
It's how much?
6.3.
I got 9.95.
What?
No, you actually guessed 40s, so.
Okay,
The absolute
20.
value.
who's in degree mode?
I'm in the.
Oh. But your shoes are sick.
Should be in radian.
6.331.
So how much is it?
6.3318, not 69412.
So almost 20.
So practically 20.
Yeah, actually, if you round a little.
That's good.
If you round a little.
Around a lot.
Round to the nearest 20, okay?
6 is close enough to 10, and 10 is kind of close to 11.
And 11 is
Kinda close to
functionally
20.
13. And 13
12.
times 2 is 26.
Yeah,
Subtract
boy, you guys
6.
were running all the way
I
up.
mean, 13 is like a nasty number, so might as well go 15.
So
Yeah, then, you know, at that
And
point-
15 rounds up to 20.
So,
you're saying when you're in college, which would be in the 20s,
he gets to truncate, I get to round.
it would be cool to date someone who is 6.
Yeah. They grow up so fast.
Awesome.
Ooh.
Disgusting.
All right.
That'll make it really-
So if you would please
Disgusting.
get out the
Oh, I do not know where that went.
sheet that I gave you
Vanilla.
just 2 days ago.
It's gone into the abyss. I can't do anything about it now.
Oh, that's the continuation. It's like, why do I have more notes?
What's the fuzzy thing that's on your
What's the what?
desk? Is that Chewbacca?
Yes.
Oh,
Oh, man.
Before his battery died, he made noises.
Chewbacca noises.
Aw, that's sad.
I can't make that noise.
Nope. Sorry.
I don't appear to have any extras.
Okay, I'll search.
So, where were we last? We had done 2 of them?
Yes.
Yes.
So the answer to the first one was
That one
that one. And the answer to
that one
this one,
is the top left on the third page.
the top left on the 3rd page, this one?
I think so.
Yes.
I had cosine in it. That's all I remember.
Okay. So now we want to find a limit. The first 2, the lower limit was 0, which made it easier. Okay, here the lower limit of integration is 3. But we can start off the same way. We know that it's going to be the limit as n goes to infinity. We want an infinite number of subintervals. And we need a counter, k, to go from 1 to n of, first of all, the width of the interval is 4, so the width of the subintervals will be 7 minus 3 over n, which is 4 over n. So we know it's going to end with 4 over n. That's the width of each of the rectangles. What we need to know is, well, what's the height of the rectangles? Well, the first rectangle is going to start at 3 plus 4 over n times k. Now, we kind of zipped through this last time. The reason it does that is we're starting at 3 and going till 7. the width of each of the little subintervals is 4 over n. And on these, they always do a right Riemann sum. And so the coordinate of this point, the x-coordinate is 3 plus 4 over n times 1. And then this one would be 3 plus 4 over n times 2. You see how that's working? Each time it's going to add on the width. So this is going to be the square root of 4 times 3 plus 4 over n times k minus 3. You can just follow along with this if you like.
Well, now this is a personal offense.
Oh, I see. So we want to simplify this because there's no way that answer is there.
It's not.
So it would be the limit as n goes to infinity of the summation as k goes from 1 to n of the square root. Let's see, that's going to be 12 minus 3 is 9 plus, when we distribute that, that's going to be 16 over n times k times 4 over n. Is that one there someplace?
Sure is.
Where is it?
On the second page, the top right corner.
On the second page, on the top right corner. Yep. All right. Now they're going to switch the order on us.
One.
So now I'm starting with a Riemann sum, and we want the integral expression. All right. So we know that 2 over n is b minus a over n, where a and b are the limits of integration. So we know the distance between our two limits of integration is 2. Part of the question is, well, where are we starting? Well, this is our function. And notice that it's 2 over n times k. Well, that's just the width of the subinterval times k. There was no plus anything. So where did it start?
0.
Started at 0. So this is going to be the integral from 0 to 2 of, that's going to give me my x-coordinate. And then I just am adding 3 dx. Hopefully that's somewhere. You know what? You can have.
Aw.
Thank you.
You're welcome. Pardon?
On the back, it's the top right.
On page
The
2?
last page.
The last page.
Oh, the last page. Top right? Yep, there it is. All right, let's do another one together, and then I will let you see if you can do the next one on your own.
Uh-oh.
All right. So because of this part, what do we know?
B minus a is 2.
Yeah, we know that b minus a is 2. Or b is a plus 2, however you want to think about it. All right, notice this 2 over n times k, that's just the width times my counter. But they've added 3.
Start at 3.
So we're starting at 3. And where are we going to go until?
5.
5. And it'll be the square root of x squared plus 1 dx.
One's right there.
Is it?
Bottom left.
Pardon?
Bottom left.
Oh, bottom left. I thought you were saying it was right here beside it. I was like, I don't think so. Almost.
Close enough.
All right, see if you can write a Riemann sum for this one. So you can look at mine, see if I agree with you or you agree with me. I don't like it when people look up and down that many times. It makes me nervous.
I'm just missing the +1.
Oh, you know what I'm missing?
8. It should be.
Yeah, it should be 8 over n. Because I didn't distribute the 2.
Should it also be 2 plus 8
No, because it's 2 minus
oh,
1.
2 plus 1.
Yeah, I went ahead and combined the like terms. Have y'all found that one?
In the front page at the top right.
Front page on the top right. Yep. All right, let's do one more. Find a limit equal to this. Well, hopefully I did that one right. I'm getting some agreement at least. Okay, you kind of see how that begins to work. This particular circuit was written by a guy named Mark Kearley, who does a lot of work for the College Board, especially during COVID when they did a whole bunch of videos reviewing stuff. He was one of the primary people who did that for College Board. And I'm fortunate enough to have met him and know him well enough to, I wouldn't call him a good friend or anything, but I know who he is. He knows who I am.
So you're famous.
No, he's famous.
You're famous by association.
Yeah.
And I know him.
So we're famous by association.
Yes.
By secondhand association.
But by association, nonetheless.
Indeed. All right, I think that's enough of those for today.